So welcome everybody. Excited to present to you today the SDS2 2022 connection enhancements. Some good stuff in here with reporting and some new connection types, enhancements to connections. So Colin and I are here today to present that to you, show you how that all works and explain the ins and outs of that. So we're going to go ahead and turn our cameras off here so that we can focus on the content, the presentation today. So quick introductions. So Colin, you've been here with SDS2 for a long time. Why don't you give us a little background on yourself?
Okay, I started in 2002 as an intern during graduate studies. Came on full-time in 2003. Became licensed and was named chief engineer in 2006, and I've been serving in that role since.
Very good. Do you remember what version of SDS2 you started developing on?
Yeah, we were just finishing with 6.2.
With 6.2, okay, so that was a long time ago. There's been a lot of changes since then, huh?
Right.
Yep. And then, a lot of you know myself as well. David Zabka here. Been here since 2006 in support, sales, number of different roles here. So our content today. So we've got four kind of main topics here. First one is unity ratios in our design calculations and a couple other formatting things that we updated to make a little bit more sense within there. We'll cover end plate web extensions. We'll look at flush frame joist clip angles, and we've added a new minimum dimension for gusset plates. We called it the shoulder dimension, and we'll have a look at what that looks like here shortly. So quick rundown of these a little bit more in depth before we show you what they look like in SDS2. Unity ratio. So Colin, I'm going to kind of give this one to you a little bit. Why do we start including this unity ratio in the design calculations, and why is this important?
Okay. Well, you see some points there on the slide. Unity ratio is very familiar to engineers and those that will be reviewing our reports. It gives you an easy way to visualize the percent of the connection capacity that's being used. So the example given there, if you have a unity ratio of 0.95, that means you're using 95% of the connection in that limit state, and you can easily tell you have 5% left. One good feature of this is you'll see some of the presentation of our load calcs simplified greatly, so we can just directly calculate interaction formula on our calcs that involve interaction. It also lets us sort the limit states from most used to least used. So in this example here, you'll see rupture of web weld was the controlling limit state, with bolt bearing on supporting member being the least concern. That kind of summarizes it.
Yeah, perfect. Very good. Very good. And there is one setup option in the project settings related to this. So you do have the option to turn the limit states off with that option. So we'll always display the unity ratio and give you the unity ratio, but we do have an option to turn the limit states off within the project settings. So one small setup option related to that. Very good. The next topic that we'll look at is our end plate web extension. So very similar to clip angles that would extend below the bottom flange of a beam. We've been adding that web extension plate for clip angles for quite a while now. We've just kind of expanded that similar functionality here to the end plates. There is a connection specification, again, very similar to what we were familiar with clip angles. To we have an option for if required or never on adding that web extension plate. Works essentially the same way as it does for clip angles. This will share bolts with opposing connections, even if the other one's upset and they're a little bit different. And then the way that we're getting this connection here and the rows of bolts and the spacing and all that is we're using the variable row spacing within the connection component, and we'll see that and what that looks like here as we hop into SDS2. Colin, one question for you on this. So one thing to point out is there is no weld on that bottom flange, and that is done intentionally, correct?
Right. We wanted to keep this a simple shear connection. So if you added a weld of the flange to the end plate, that would make the connection much more rigid. So you start taking some moment. So to avoid that and keep it flexible, we are not welding the flange to the end plate.
Okay, very good, very good. Next step, we got the flush frame joist clip. So in the previous release in 2021, you might recall we added this connection for a shear plate, and clips are very common as well in this case. So we've kind of expanded the joist connection here to include the clip angles for the flush frame joists. Keep in mind, this is a Volcraft design. So in your project settings under your joist manufacturers, you do need Volcraft to be set up to be the joist manufacturer. Otherwise, you would just have to force that connection, since it's not if you don't have Volcraft as that manufacturer. Some of the defaults you'll see here, and again, this comes specifically from Volcraft and the design that they have used to kind of try to standardize all these connections. We're doing single-sided clips, 1-inch bolts, 3 rows. So this allows on the Volcraft side for that design of these to be very standard. So they like to see that, and that's why we went with those defaults. Can change them, that's up to you, but those are the defaults that we provide out of the box. Anything to add there on that one, Colin, that I may have missed?
I guess I would just point out that the default bolt diameter and the default rows use those same setup fields that the flush frame shear connections use. So you can find that in joist connection settings.
Okay, perfect. So kind of the last topic here that we'll cover today is this minimum shoulder dimension. So I've given a kind of a design example on the right. I've highlighted this 2-inch minimum typical dimension here that we see a lot. If anybody was at SDS2 Summit, or I gave this example in a presentation that I did, and I struggled very, very much with it because in the past we always had to adjust your plate length and width, and then you had to figure out, okay, after you adjust that, then I got to adjust the clip dimensions on the corners and everything like that. So we've now added a minimum dimension for that. It's in the project settings within Gusset plate settings, and we've actually broken that out into 2 fields for both welded and bolted connections. And as Colin pointed out to me as we were prepping for this, rod bracing will use the welded setting that we have in there. So, questions or anything to add to that, Colin?
Just a little explanation on the rod bracing.
Yeah.
Using the welded setting. We did that just to kind of maintain old functionality because those, when they were first implemented, they were using the same shoulder as the connection that you see in the detail here, the welded HSS. So we went that route.
Okay, very good, very good. So that kind of just covers what we're going to do, what we're going to show you here. So let's open up SDS2 and have a look. So I'm going to start out with the unity ratio in those design calcs. So first thing to point out with that is the project settings. So that's in our design settings. And we now have a reports leaf in there. And we just have a simple checkbox to show the limit state capacities or not. So, you know, that limit state that you're always familiar with, always have seen in SDS2 in the past, we now have the option for that. Unity ratios will be shown always. And correct me if I'm wrong on any of this stuff, Colin, but we're going to see on my end plate connection here. There we go. So I just have a simple end plate connection to kind of mess with here. It's a safety connection. So we can see when I edit a connection component, we have the limit state table as we've always seen over here on the left. We now have the unity ratio in there, and we have the limit states. Now, if I have that project setting turned off, the limit states will or will not show here, Colin.
So that affected everywhere. So that you would not see the capacities there, and you wouldn't see the capacity on the report.
Okay, perfect. Very good. Very good. So if I go ahead and run a expanded calc on this member here, so my end plate's on my right end of here, I'm just going to output that as it is there. And when we get that PDF generated, that's going to open it up in Bluebeam for us. So, you know, pretty standard, pretty basic. I said this was on the right end of our beam, so I'm going to use my bookmarks over here, and I'm going to navigate down to the right end. One of the things that we should point out to you here, I believe there is some input information that we have changed. And am I looking in the right spot, Colin, or am I?
Yep, yeah, there it is right there. Up a bit higher. There you are.
There we go.
So that used to be input summary, which means if you had an input connection type of auto standard, this section of the report would just show auto standard. And feedback from users told us showing the actual design connection here would be much more useful for reviewing connections. So we've made that change.
Perfect, great. So yeah, so if you were sending something out to, you know, be reviewed by an outside engineer, somebody who's not familiar with SDS2, auto standard didn't make sense to them, or, you know, there's times in SDS2 where maybe a clip angle could be changed to a shear plate because of framing situation checks or whatever. So now we're actually showing the actual design summary, design information here versus what was just input on the edit window. So that's great there. And then if I come back down to my right end and look at my design strength summary for that end plate we were looking at. So here's where we see the unity ratio again in the limit state table. We do still have the limit states shown there, and you'll notice it is sorted, so it makes it a little easier to read for us there on the sorting as well. Anything else you want to point out in here, Colin, that you feel like might be important that we've changed or updated? Or
yeah, one important thing I forgot to mention as a part of this project is when we have interaction of loads on connections. So for example, an axial loaded beam connection, we now will call out the limit states that have that interaction with an asterisk near the capacity. And we wanted to do that just to make it clear which limit states included that interaction, and because feedback told us that that sometimes was misunderstood. So we wanted to be show that more clearly.
So we would probably have something like that on my beams over here,
Right.
with that vertical brace framing into that same intersection point there.
Right.
So if we want to just go ahead and run that, take a look at that quick. So I believe in this particular case, I've got this set up to use special case 2 of the uniform force method.
Okay.
And then we'll see this info. So that was on my left end. So we're going to go into the design strength summary again. There we go. There we see the asterisks.
And there you'll see some asterisks. Yep. And below the table there, you'll see a note. That's just calling attention to the fact that that 53 kips for your controlling limit state is only true if all other loads on this connection remain the same. So if you were to change the tension on that connection, then the shear capacity of bolt shear on web bolts would actually be decreased.
Okay. Very good. Very good. So that kind of summarizes then the unity ratio, the design calcs, kind of what we've updated in there. The next thing for us to have a look at then is our web plate, end plate web extensions. And let me kind of isolate this joint a little bit so we're not getting stuff in the background in the way here. So I'm going to hide unselected. I may just go ahead and turn that all to solid transparent main so we can see a little bit better what's going on in there. And a couple ways this web plate extension can happen. So first off, if I come in here and maybe I'm going to adjust my loads a little bit. So maybe if we've got a specific loading requirement, 80 kips, just going to slide this over, get our preview. Okay, so we can see I do have that safety connection on there. So it is still giving me the safety connection in this particular case. You know, I could come in here, override that safety connection now that I'm not sharing all the bolts in there. So, you know, we may be able to do something like that where we're getting that shared. If I edit that other side, you know, I'm going to be able to do the same thing. So again, maybe there was a specific loading requirement, maybe the 80 kips on there. I can get that. Even if this is upset a little bit, so for whatever reason, I'm just going to say that's maybe upset a little bit, about 2.5. And I'll turn that safety connection off again. Okay, so we're sharing bolts. We got all that in there looking pretty good. So we do have the connection specification in there as well, like I mentioned. So inside the edit window again here, if I come into my connection specifications, left end I have an auto standard connection, right end we do have the option to use that extension plate. If I set that to never, I'm going to get a failed connection because that's going to be required here to get that end plate to go down. So very similar, like I mentioned, to the way clip angles works with regards to that web extension plate there. Other things to point out and to know with that, if I just edit the, excuse me, I didn't want to grab the member. Let me grab the connection component here. So if I grab the connection component and look at some of the variables within here, you're going to notice that the, excuse me, let me adjust the rows. So maybe I'll go in here and say I want 5 rows of bolts. So I can lock my variables and still get that web extension plate on there. The vertical hole spacing, you'll notice, uses variable spacing. So That's to kind of clear that bottom flange. You know, with if we were looking at a clip angle connection, we'd have to cut the flange flush on both sides and everything so that our clip angle can clear that and extend down. So in this case, since we don't have to do all that in order to clear that bottom flange, we can use the variable hole spacing in there. You see we got 2 spaces at 3 inches, and then we got one at 6, and then, 6 and 5/16, and then another one at 3. So, and you know, you can override that just like anything else. So if I were to go 3 in there, might be a little tight on my clearances there for my bolt clearances, but I can override that and get some different results there. So, anything else we should point out or mention here on the end plates, Colin, or is that cover most of it?
No, I think you covered it.
Okay, very good. So then let me show the rest of my members here again. Again, I'm going to go ahead and say change all to solid transparent main. So the next thing to look at then is that flush frame clip angle for joist. So I have this set up in my auto standard connections to use that flush frame clip. So if I were to come out to project settings and show you my auto standard connections, you're going to see from beams to columns, I have a flush frame clip option in here now. By default, we're set up as bolted, all that as we mentioned. If I do a search here for my joists and I go into my joist manufacturers, this is where I mentioned that we need to make sure that Volcraft is set up as the joist manufacturer. Otherwise, we're going to have to force these connections. So here you see I've got Volcraft as my joist manufacturer. And finally, if I find the right spot here in my joist connection settings, I've got a minimum number of rows that's going to affect this. That's our default number of rows that we have there. And then we had, you know, things like our bolt settings, our default bolts for K-joists and all of that. So just a few different settings that are going to affect this design. And if we take a look then in my edit window, I do just have auto standard set here. If I need to override something, I can do that. And I do have an additional flush frame clip option in there. And then just like anything else, this is a connection component that I can double click on, adjust my variables about that connection right within here. So something else, anything else I need to point out in here, Colin, or is that kind of what we got for the flush frame clips?
I would just point out that if you were to edit the joist member, you would get all the conspec options that you're used to seeing for a beam clip angle. So you can change these to welded if you like.
Okay, very good. So yes, so if I change that from auto standard to the flush frame clip, you got to see the connection specifications in here to, you know, bolt weld, which side that clip is on, all that. So very good to know. Last topic we have to cover here then is that gusset shoulder dimension. So this is my favorite, just because I know what users had to go through in the past in order to adjust this. So if I come in here and just to kind of show you all right now what we have. So remember from my slide, the shoulder dimension is the distance from the face of my tube in this case to the corner of my gusset. And if I were to add a dimension on there for us, okay, we've got a 1 inch right now. So 1 inch, that's probably what we have set up as the minimum in setup. So I'm just going to type in shoulder here to find that. That's in our fabricator settings under gusset plate settings. And you can see here that minimum shoulder width for welded end fittings is 1 inch. Let's say I go to 2 inches, because that's what was on my PowerPoint in that design example that I showed. I'm going to set that to 2 inches. Okay. I'll come in here. I'm going to grab, I'll just update maybe all of those braces for us here. Okay, so we can see just already my construction lines are off. My dimension is off here. So let me get rid of those. And that dimension, I'll go ahead and re-add that just to verify and prove to us what we're seeing there. So now we've got 2 inches as the minimum here. I can measure that other side here, and we're going to see that as well. 2 1/16, probably a slight rounding issue going on there. But we can see we're getting that minimum 2 inches. So do keep in mind that is only in the project settings. So in the setup portion, we don't have control over that on an individual basis right now. You know, typically in my experience, we're typically seeing that as kind of an overall project requirement. So, and then again, you know, we had that is separate for bolted versus welded connections. So in my project settings, I believe the bolted was set up to be 1/2. So if I were to come in here and change my my tube end fitting, so I believe, correct me if I'm wrong, Colin, welded would be the only one used in that welded setting. All these others, bolted, paddle plate, double paddle plate, that would be used in the bolted.
The paddle plate actually is welded to the gusset, so you would get the welded shoulder there as well.
Okay, got it. I'm just going to do a simple bolted. And just to, again, kind of show you, it will update, will change that. So now we got a lot smaller configuration there again, just because that minimum was set up to be 1/2. And in this case, we're going to see that not from the face of the tube, but now it's from the face of that bolted plate, and we got the 1/2 inch for us there. So that's matching again that minimum from setup. Anything else to add or point out on that particular enhancement there, Colin?
I just wanted to confirm the difference you saw earlier with the 2 on one side and the 2 1/16 on the other side. That is just because of overall rounding of the gusset dimensions.
Sure. Yep.
So those values in setup are minimums. So if necessary, we'll round up.
Correct. Very good. Very good. Okay. Well, that's kind of what we got for you here today. Just a couple upcoming events that we have for you here. So hopefully we'll see a lot of people at NASCC this March out in Denver. You know, that's been canceled the last 2 years for reasons that we're all aware of. So looking forward to doing that in person and seeing everybody in person out there in Denver. And then SDS2 Summit this fall. So we've kind of pushed back into October a little bit this year, but we are going to be down in San Antonio for that, right on the Riverwalk there. So should be a great time and good learning experience, all that good stuff. So hope to see everybody at both those events if you can. And then just before we kind of head to the questions portion here, I just want to say a big thank you to everybody for joining us. If you need to reach out to us, contact us. We got email addresses, phone number over there on the right. So Colin and I will stick around here for a little bit and answer questions that are related to the topics that we've covered here today. Okay, so there's been a couple questions come in here. One related to the unity ratios that we may not have shown there. So the question is on the unity ratios and the expanded calculations, does it show the unity ratio at the end of each expanded calc section, or is that just in the summary at the start? And the answer to that is yes, it should be in each calculation, kind of show it. They're the same place as you would typically see the limit state there, I believe, correct, Colin?
Yes, you'll see it calculated for every limit state.
Okay, very good, very good. I do see a couple other questions there, maybe a little bit unrelated to our topics today. If there's specific connections that you see all the time, or limitations with SDS2 that you run into, definitely reach out to your support rep. I gave my email address there at the beginning of this as well, so you can email those issues to me, but I want to try and focus on the related topics here of what we presented in the new enhancements here today. If you need stuff for the future, definitely let support them reach out to them. Another question here is related to the web extension plate on the end plate. And the question is, does that extension plate can that extension plate go above the top flange? I believe today it will only go below the bottom flange. We haven't adjusted it to where it goes above the top flange. Is that correct, Colin?
Yeah, that's right. It's just like the clip angles where it's only below the bottom flange.
Okay, okay. Another question that I'll try to address, so it's related to the joists and which members I believe the question is referring to the field bolts there, if I had to guess. So that's related to where do which member do the bolts get associated with? I believe that follows, there's a project setting to list your field bolts with either the supporting or supported member, and I believe that will follow that. Potentially probably need to do something slightly different with joist there. I can see that. So so somebody's saying they needed 2 different shoulder dimensions for bolted connections. So in that case, yeah, it's only a project setting right now. It's not like a lockable variable. So I would say in that case, what you're going to want to do is set up that project setting to be, the more common case in your project, and then you're going to have to adjust the plate similar to what you did in the past, where that's a different shoulder dimension. So, yeah. And then do we clip another question here is on the end plate extension again and clipping the corner at the flange. Do we clip the corner of that, Colin? Do you know?
We do not. Since it's not welded to the flange, since the flange is still not welded to the end plate, we're not clipping the corner. That's a request we can obviously add.
Right, yep. Okay. Everybody loves the shoulder dimension here. There's a couple comments about that, so I'm not going to repeat them, but they're making me laugh. I know that. So, Yeah, not a ton of questions here today. Again, if you do have more questions come up, if you've got specific connections you see all the time, limitations, something that you're always struggling with, definitely let us know. Obviously, can't address every single thing here today, but even as much as I would like to, reach out to us. You've got my email, you've got support's email. Let us know. We always like to hear from everybody. So questions kind of stop coming in here, and I'll just end it here then. So just again, big thank you to everybody. Appreciate you coming today and learning and seeing what we've done new. So appreciate your time, and we'll see you the next time.